floor is yours. Nadia, Mandy, start recording.
So I
Hello,
have so
everybody.
many names today.
Hello, everybody. My name is Hubert Makuła, and I'm the worker of the Department of Environmental Monitoring in the Central Mining Institute in Katowice in Poland. And I would like to say something about my doctoral thesis, and its title is A Critical Raw Material Recovery from Sediments which are created due to release of radium-rich formation water. Why have I chosen such topic? It is really simple because it is strictly connected with the place where I live and where I work, because I work in Katowice, and this is the city in the southwestern part of Poland, which is the part of the Upper Silesian coal basin. And the core of the problem can be discussed in two aspects. One is strictly connected with geological structure, and the second one is connected with technical aspects. And we have to start from the exploitation of deeper and deeper coal seams, because there is the main reason of appearance of new inflows of underground waters. And taking into account the fact that we have a conducive geological structure, a thick layer of clays on shales about 700 meters. It is the natural barrier which is responsible for enabling mixing waters from different depths in the orogeny. And these underground waters become highly mineralized brines, which are the main carrier of radioactive nuclides. And on the other hand, we have the technical aspects, keeping underground galleries accessible for miners. And it is strictly connected with removing underground waters into the surface waters, and taking into account the fact that these formation waters are the main carrier of big amount of suspension. There is a necessity before releasing them into the surface waters, there is a necessity to keep them in settling ponds to purify them from the suspension. And it is the main reason of formation sediments. These sediments are the mixture of different minerals, and among them there is also a sulfate of barium. And taking into account that the barium and radium have the geochemical affinity, we have to observe the fact that radium enters the structure of the buried, and it is the main reason of the fact that these sediments become a main source of high content of radionuclides. And the core of the problem is connecting with finding an answer connected with an issue of zero waste solution, because I would like to use flotation method to separate buried as the main carrier of radium from the rest of the mixture. And on the one hand, it would be able to obtain a material which would be a mixture of gangue minerals. I think about quartz and clay minerals, which can be later used for the production of building materials. And on the other hand, it would be obtain a starting material for the following research to get at the end clean concentrate of radium, which can be used for treatment of people, and on the other hand, which a concentrate of buried, which could be used for example, for drilling. In my PhD, I would like to characterize these sediments, and it is necessary to perform some tests. I think about making mineralogical tests thanks to using XRD method. Moreover, physicochemical tests thanks to using X-ray spectrometry. The measurement of activity of radionuclides can be determined thanks to using high-resolution HPG gamma spectrometer. And the second part of my PhD will be based on the performing flotation tests. And these flotation tests will be performed thanks to using mechanobor type flotation machine. And moreover, I would like to add that these methods, XRD, XRF, and HPG gamma spectrometry, will be used as a checking method for the material after flotation method. What
You're already
are
speaking
the...
6 minutes, Hubert, just to...
Okay. I would like to end, and I would like to add that the main difficulty is finding the appropriate collectors or framing agents and appropriate conditions to perform this experiment. And thank you so much for your attention.